Section 3.2, now that we know about radian measure, we're going to have some applications using radian measure. So you use radian measure in the following two formulas. Finding the arc length, so that's the length of this arc here, S, and S is r theta, but theta always has to be in radians. So if you're given the problem and it's in degrees, before you start working, you want to change it to radians. Find the area of a sector. That's this green part here, the green part. So if you want to find the area of a sector, that is A equals 1/2 r squared theta, where theta is in radians. So some samples of that would be, find the length of the arc if theta is pi over 2 and r is 4. Well, that's simply multiplying 4 times pi over 2, reducing, you get 2 pi. Find the length of the arc if r is 12.3 and theta is 2 pi over 3. Again, you're just multiplying 12.3 times 2 pi and divide by 3. And I would say typically use your pi key unless it tells you to use something else. All right, find the arc length given this r and that theta, and you've got 4.82 and theta is in 60-degree mode. So before we work, we want to change that to pi over 3. So now you have 4.82 times pi over 3 equals 5.05 meters. Find the measure of the central angle shown. So you're given this picture, and 3 is the area of the sector. So we need to remember the formula for the area of a sector is 1/2 r squared theta, and we're trying to find what theta is. So fill in 3 for the A, because they give you the area, equals 1/2 times 2 squared, 2 is your radius, theta. So 2 squared is 4, half of 4 is 2, so you have 3 equals 2 theta. Divide by 2. Theta is 3 over 2, or 1.5. Find the area of the sector, and you're just going to plug in what you got. So 1/2 r squared theta, 1/2 r is 29.2. You're going to square that, and theta is 5 pi over 6, and you get something like that. So it's just using the formula. Find the central angle if A is 16 inches squared and R is 3. So in this one, here's our formula. We are given the area. So we've got 16 equals 1/2 times 3 squared theta. So that's 1/2 times 9 theta equals 16. And that's 4.5. And we're going to divide 16 by 4.5 to get theta, and we would get 3.6. All right. Latitude, I don't know what that's doing in there, gives the measure of a central angle with the vertex at the Earth's center, whose initial side goes through the equator and the terminal side goes through the given location. All right, so say you had the central angle between Reno and LA is 40 degrees minus 34 degrees, so that would be 6 degrees between Reno and LA, because we knew the LA to the equator. The distance between the cities, S equals r theta. So that's your arc length. All right. Whoops. So convert 6 degrees to radians. That would be pi over 30. And so S equals r, which is 6,400, that's your equator, times pi over 30, which is 670 kilometers. That's an example. I think we'll have a problem like that in the problem set. 2 gears are adjusted so that the smaller gear drives the larger one, as shown in the figure. if the smaller gear rotates through an angle of 225, through how many degrees will the larger one? So it's saying if you move this many degrees in the small one, how much does this move? So first of all, we change 225 to radians, and that's 5 pi over 4. So we want to find the arc length on the smaller gear. So we have the radius up here of 2.5, and we multiply it times 5 pi over 4. And that gives us 25 pi over 8. You had to multiply by 10 to lose the decimal. So if I multiply that by 10, I get 125 pi. And when I multiply by 10, that decimal moves there. So I have 125 pi, but I had to multiply by 10 here, and I got 40. And then when you simplify that, 5 goes into both of those, 25 pi over 8. So that's kind of how we got that. And then the tips of the two gear teeth must move at the same linear speed. So the arc lengths have to be the same. So we've got 25 pi over 8 has to equal 4.8 theta. Where did the 4.8 theta come from? S equals R theta. Remember? So the arc length here is going to be 4.8 times theta, which we don't know. So S equals R theta. The smaller one is 25 pi over 8 equals 4.8 theta. 4.8, you want to multiply by 10, so we have 48 over 10, which if I divide 2 into both of those, I get 24 over 5. So it's like I have 25 pi over 8 equals 24 over 5 theta. When you divide by 24 over 5, it's multiplying by the reciprocal. So that's what happened here. And then that gives you 125 pi over 192. And you want to change to degrees because it asked for, I believe it wanted how many degrees. So 125 pi over 192 times 180 over pi. The pi's cancel out. And when you multiply 125 times 180 and then divide by 192, you're going to get the 117. So we're going to see that again in the problem set. So let's go look at our problems that you'll see in your homework. So for the first one, find the exact length of the arc intercepted by the given central angle. So the radius is 14 and the angle, the theta is 4 pi over 3. So S equals R theta. You're simply multiplying, so you have 56 pi over 3. And it does remind you to leave your answers in terms of pi. So on this one, your theta is 2 pi over 3. Your S is given, so you have 17 pi for the S, and so we're looking for R. 17 pi equals R times 2 pi over 3. When you divide by this to get rid of it, you flip it, so you have 3 over 2 pi. The pi's will cancel out. 3 times 17 is 51 over 2 equals R. Again, we are looking for R. 9 pi is the arc length. Theta is 5 pi over 4. When you divide by 5 pi over 4, you flip it. And then you have your 36 over 5 is your R. For number 4, how long is an arc intersected by the given central angle in a circle of radius 18.57 miles? And you have 45 degrees. So you're given the angle as a degree, so we have to turn it into radians, and that's pi over 4, and then 18.57 is your radius. Multiply those together and use your pi key. So 18.57 times pi, and then divide by 4, and you do get 14 point, and it says round to hundredths, so 14.58 would be our answer. All right, here is two cities that have nearly the same north-south line of 112 degrees west. The latitude of the first city is 25 degrees, and the latitude of the second is 36 degrees. And we had one like this in the lecture notes. So theta is going to be the 36 minus 25. So there's our 11 degrees. Then we're going to change it to radians. 11 over 1 times pi over 180 equals 11 pi over 180. And so then we're going to put that in. Here's our radius is 6,400 because that's the average radius of the Earth. And 11 pi over 180, we should get, when we do it over here, 6,400 times 11 pi, we get that number, divide by 180, 1228, and it says round to the nearest integer, so that'll be 1229. Number 6 is the two-gear problem. So the first thing we're told is the smaller gear rotates through an angle of 300 degrees. So remember, we changed that into radians, so that's 5 pi over 3. So we want to figure the arc length for that one. R theta, 3.7 times 5 pi over 3, and we had the decimal, so we multiplied that by 10. Multiply by 10, and that gave us 185 pi over 30, and then simplify that. We get 5 will go into both of those, so you have 37 pi over 6. Then we know that that arc length has to equal this arc length, the 7.1 times theta. So we'll divide by 7.1, and 7.1 is the same as, if we want to get rid of that decimal, if we multiply it by 10, it's like, well, it's 71 over 10. That's the easiest way to do that. That's the same as 71 over 10. Because it's 7.1 over 1, and you have to multiply top and bottom by 10. That's the easiest way to think of that. Then you flip that when you divide. So we have 10 over 71 times that. That gives us 370 pi over 426. We got to multiply by 180 over pi because we need it in degrees. The pi's cancel out, and we will, once you multiply and then divide, you get the 156. Here is another one. So for this one, we have the same idea. The smaller one rotates through 30 degrees. That's pi over 6. So 5.15 times pi over 6. And we need to get rid of the decimal, so we're going to multiply by 100 on top and bottom. We get 515 pi up here. We get 600 down here. And you can reduce, you get 103 pi over 120. Now, that amount has to equal the 8.18 theta. And 8.18, we're going to multiply by 100 on the top and get 818. On the bottom, we had a 1, so that became 100. When we divide by 18 over 100, it flips. And so when you finally do all of that, you get 18.887, and it says round to the nearest tenth. So we had 18.9. Then we get to some areas of the sector. Find the area of the sector shown, and we needed to find theta first, and so S is R theta. So the arc length is 3 pi, and the radius is 4, and that ends up with a theta of 3 pi over 4. Then to get the area formula, we plug in, we have the radius, which is 4, so 1/2 times 4 squared times 3 pi over 4. 4 squared is 16, half of 16 is 8. So over here, 8 times 3 is 24, divided by 4, we get 6 pi for a final answer. Number 9. Find the measure of the central angle. You are given only that the radius is 4, and it does tell you that the area is 8. So here's our formula. We're going to plug in 8. 1/2 times r squared, 4 squared. So that is 8. And when we divide the 8 over there, 1 is theta. It is in radians, not degrees. Number 10. Find the measure in degrees of the central angle. The area of the shaded sector is 288 pi. So we're plugging in. Radius is 18. The area is 288 pi. 18 squared is 324. Half of that is 162. Divide by 162. So this is our theta in radians, but we need it in degrees. So we multiply by 180 over pi, and the pi's cancel out. You'll always know if you have it right because the pi's need to go away if you're going to have degrees. And you end up with 320 degrees. All right, let's move down. A center pivot irrigation system provides water to a sector-shaped field as shown in the figure. Find the area of the field if theta is 135 and r is 24. All right, so 135 we need to change to radians. So times pi over 180. 45 goes into both of those, so 3 over 4 is the reduced part. So we got 3 pi over 4 for theta. R is 24. That was given right here. And so we have 1/2 times 24 squared, which is 576, times 3 pi over 4. That ultimately gives us 216 pi, but we need it in, it says round to the nearest integer. So we multiply 216 times pi, we get 678.5. That becomes 679. So those are some applications with the radian measure, and hopefully after doing a few, you will feel more comfortable doing that.